Schemalint is a tool I like to use in conjunction with Kennel. I've already spoken about how I like linter rules and how I think they have the potential to be much more than just code formatting rules. I like to refer to them as architecture assertions. So they're sort of little rules that define this is the way we write code in this particular project. And when we're letting the database be our source of truth, like we're doing when we use Kennel, and the Postgres is sort of driving the architecture, there are certain rules that have to be enforced at the schema level if we want to do so at all. And that is what Schemalint allows us to do. We'll start by installing it as a developer dependency in the schema package. And I will just copy this configuration file and we can try and run it and see what comes out. So schemalint rc.js. This is again a JavaScript configuration file. Let's try and run it. So we get 4 error messages and a SQL string for a suggested fix here. Let's quickly take a look at what our actual migration looked like. So this is the users table that we have. It has an ID, which is a serial primary key, an email, which is a 255 character varchar, and the same goes for password. And let's take a look at the configuration file here. So the rules that we have set up, these are all built-in rules in Schemalint. So the real power comes from when you start to develop your own rules. But it does have some useful built-in ones, and these are the ones that we're using here. The first one is name casing. So we're specifying that we want to use snake casing, which is sort of a Postgres standard. So that means words are separated by an underscore. And Postgres suggests that you do that because if you use uppercase characters in your names, which is possible, then you have to enclose all of your names in double quotes whenever you write a SQL statement. And that can be just a little bit tedious, so it's easy to forget and you can get confusing error messages. On the other hand, you may consider wanting to do so because it will make the naming consistent with what you might have in your TypeScript types. So I don't think I have a very strong opinion on it, but for this, we're using the default, which is snake case. So we're saying if anything is named with anything other than snake casing, it should report an error. However, our users table is just called users, so there's just one word. So actually, we can't know whether or not this is snake case or not, but it's a perfectly valid snake case name. The second rule we're using here is name inflection. And so we're saying we want singular names. And that is a matter of a bit of controversy in database world. If you want to name your tables singular or plural, there are pros and cons to both. I tend to like using singular. That means that my database names are consistent with my type names because I want to refer to a user in my code, not to a users, which you may recall is what Kennel actually generated for us. So we have this interface called users here. And that is misleading in my opinion because this is reflecting one instance of this. So we could make it so that this was actually changed. Obviously, the casing here has already been changed, so you could argue that it's perfectly fine, and I believe that this is what they do in Ruby on Rails, for instance. But I think personally that it's nicer to have my database tables named singular, so that just matches what I have. And I've set this rule up to try and enforce this here. One thing to keep in mind is that inflection is difficult. It's much more difficult in many other languages, but even in English, there's a lot of irregular words. So trying to figure out if a table should be called person or people it's not always just a matter of whether or not it ends with an S. So this uses a little dictionary that was available online somewhere, but you may find that if you're using some very unusual words, it won't catch whatever you're doing. So that's a little bit to keep in mind. But for most words, it should work, at least if you're using English. The third rule here is something that doesn't apply to anything we have just yet, but I always think it's nice to put in place. So it says that if any column is of the JSON type, it should probably be JSON-B instead. So the JSON type was introduced in an older version of Postgres, and JSON-B is superior in just about every way. So it stores the JSON in a binary format instead of just the raw string, and that allows some better indexing, some better queries, and some better performance overall, better storage. But there may be a few situations where you want to use the regular JSON, but as a general rule, this is what you should be sticking to. So we'll set up that rule just to have it in place already. The fourth rule here is what we're actually seeing 2 errors of as well. So email and password are both of the varchar type, which is something, if you've been coming from SQL Server or MySQL, that may seem intuitive to you. But in Postgres, they actually recommend officially that you always just use the text type, which is of variable length, and it doesn't have any implications in terms of performance or storage space. So creating this artificial limitation to how many characters your string can have is actually not getting you anything. So that is why the official recommendation is to always use the text, and that is what we're being told down here that we should do for both the email and password columns. And you can see down here that it suggests how we might change it if we want to create a migration that does that. The final one is that we should prefer identity to serial. So we're using this serial type here, which is a sort of macro that Postgres has that creates an index and turns this into a numerical type. The identity is more of a SQL standard, and the good folks at Postgres are now suggesting that we should use that instead. The Schemalint documentation has links to explanations for these rules if you want to look further into it. You may want to make exceptions to it, but for now, we're going to use this rule as well. So there's a little suggesting how we can alter our table here. I think we'll just change our migration, but if we wanted to make a new migration, we could use pretty much this SQL that is suggested here verbatim. Just to finish up what the configuration states, here it says that the schema we're going to be looking at is the one called public. That is the only one we have right now, so that makes perfect sense. We might install some plugin or something that creates an additional schema, and if that runs its own database stuff, maybe we don't want to run any linting rules on that because it's a third-party thing. And finally, we want to ignore the 2 next migration tables because they're out of our scope. So if they were named, say, with a different naming convention that we would prefer, or if any other rule might break on those 2 tables, we want to not care about it. So we're specifying that these 2 tables should ignore any rule that is failing on them.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.